Hey everybody, I want to make a really quick video tonight here. I'm working on an Ethernaut smart contract hacking video here, and we're going to make that video tomorrow. But I want to show you guys something that's very important to understand as a smart contract developer and just working with smart contracts in general to make sure that your code is secure and make sure that everything is good to go. So a lot of you guys are probably familiar with the require statement, and this is going to kind of lead into the video tomorrow, and it might seem obvious right now, but if we don't understand this here, we're not going to kind of understand how this kind of crack the smart contract from here. So what I'm going to do is first up here, let's go ahead and make a new file. Let's just call this video.sol, and we're going to copy over another contract just to make life a little bit easier from here. So I went ahead and made a new file from here. I set up this smart contract. It's basically the skeleton of a smart contract from here. What I'm going to do at the very top is I'm going to set a uint, uint 256. Let's make this public, and let's just call this num. Let's call it A for right now. That seems to work here. Let's go and set up an address. Let's make this public, and let's set up the owner. And a lot of smart contracts follow this similar pattern from here. So let's go and say constructor, and we're going to open this up here, and let's set owner equal to msg.sender. Right, pretty simple from there. Now I'm going to set up one more function from here. Let's go and set up, I'll tell you what, before we do that here, let's go and set a equal to 1 for right now. Function, let's say increase number. We're going to make this a public function, and we're going to say a plus equals, if I can type something, 1. And then we're going to say require. So a lot of you guys, of course, are familiar with the require statement from here. We're going to require that the msg.sender is equal to the owner. Otherwise, you are not allowed to do that. So a very simple contract from here. A lot of you guys can already guess what's going to happen from here. But like I said, it's important to understand this concept. And again, it might seem very obvious right now, but this will lead into the video tomorrow here. So let's go ahead and compile this from here. Let's go ahead and deploy this to the VM. And we can see that if we look up the number, if we look up the owner is the same address that's here. And then we have the number 1. If we increase the number, that's what we should expect to happen. The number increases from here. Now, if I switch my wallet address to something else here, even though this statement is above the require statement here, this isn't going to run, right? Like if I try to call this this function from here, increase number, we can see that the transaction has been reverted to the initial state here, and this number remained the same. Again, it seems very obvious from here, but what I'm going to do is I'm going to leave you guys with a little bit of a cliffhanger. If we look at this contract, and we see all this happening from here, and we see this return statement from here, could we use the require statement to see if we're returning this, and if we return a true or false value, and if the wins increase or not? Well, stay tuned tomorrow to find out, guys. Catch you guys then.